Alrighty, ladies and gentlemen, welcome to lesson 1-3. We're going to look at this lesson called significant figures. In the previous lesson, we talked about uncertainties, right? How every hash mark in a ruler kind of has like a space in between. And that space in between shows us that every measurement has some level of uncertainty, meaning that if it doesn't fall exactly on the hash mark, we don't know for sure if that's the exact measurements. So, this lesson is about how do we actually know what numbers are certain and how can we help increase our precision when we're making those awesome chemistry calculations. Alright, so let's look at this. What is the difference between the values 3, 3.0, and 3.00? So you might be thinking, hey Mr. Tran, those are all 3's. What's the difference? There actually is a difference if you look more closely. So this 3 right here could actually be a 2.9999. It can go on forever, right? And even though 2.9999 is really close to 3, it's not exactly 3. Okay? So same thing with 3.0, right? 3.0 could also be 3.1259, right? It can be a little bit higher than 3, but not exactly 3. So therefore, 3.00, right? I know for sure it's a lot closer to 3. Even though it might have like numbers in the back that might be rounded up like that. But I know for sure it's definitely closer to 3 than these two guys over here. Alright, so based on knowing what digits count as significant, meaning that this is more accurate, there are certain rules. But before that, let's just talk about significant figures in general, okay? Like I said before, instruments have levels of uncertainty. They can never be fully precise because there are gaps in between each hash mark, meaning that any hash mark missed or in between, you cannot really know the exact measurements. The number of digits reported are considered significant figures to determine the precision of the measurement. So those are the numbers I know for sure, and it helps solidify my calculations a lot more because even one little tiny thing, that could be off in calculations, especially if you're doing like nanotechnology with like really small objects, that could throw a lot of things off. So chemistry likes to be precise. Okay. And we're going to talk about rules for determining the number of significant figures, precise numbers. Alright, so first rule, non-zero numbers are always significant. Meaning, if I have 72.3, right, every non-zero number counts as a significant figure. So that counts as 3 sig figs. Alright, zeros between non-zero numbers are always significant. So if I have this right here, a 0 in between, okay, two non-zero numbers, then this 0 also counts as a significant figure. So I still have 3 sig figs because that 0 counts. Sandwiched. Alright. And, okay, but zeros before or to the left of non-zero numbers are not significant. So if I have these guys right here, these zeros, where's my notepad? Okay, these zeros right here do not count as significant figures. Okay, so I only count the non-zero numbers here, which count as only 3. So any zeros to the left do not count. Alright, and the fourth rule, all zeros after or to the right of non-zero numbers are significant if there is a decimal point. Okay, that is a big if factor. So let's look at a couple of examples. 123.00 has 5 significant figures because it has a decimal here. So these 3 sig figs and also these 2 zeros count to have a total of 5 sig figs, okay, because of that decimal importance. Alright, so 2,000 to 12,000 only has 2 sig figs, okay? Why? Because there's no decimal here. Okay, there's no decimal there, so these zeros do not count, and only the non-zero numbers in 12, okay, for 12,000 count as significant figures because there is no decimal. All right. Okay, so 120.0, right? There's a decimal there, so therefore these zeros do count, so give me a total of 4 sig figs. All right, and 12,000 with a decimal, right? With the decimal right here means that these zeros right here do count. Okay, so I should have a total of 5 sig figs because of that decimal right there. All right. So I want you to try these and count the number of significant figures in these numbers. All right, you're gonna match them up, and just remember the full rules. Okay, so any non-zero number, right? Zeros in between count. Any zeros before, okay, do not count. And then any zeros afterwards, right, to the right of, only count if there's a decimal. Alright, go for it.